All right, so the first of our four strategies is the one that is on the bottom of the front side of this packet. It's probably the most commonly used one. All of these are situational, so like the more you've done, the more you get used to these, which isn't going to happen yet. That's something that happens next year, but if you can get even a little bit used to them right now, you'll be okay. It's the one where we use some just substitution right away. Okay, so strategy number one, rewriting things using sine and cosine. Okay, when do we use this strategy, or when is it really handy? It's really handy when the trig functions are either being multiplied together or divided. So the two examples that I used, here we have two trig functions that are being divided. Here we have two trig functions that are being multiplied. When I have a situation that's like that, then I'm usually good to go for doing this, because when I have multiplying and dividing, I can get stuff to cancel out. Okay, so that's kind of the goal, is to take something like this and to simplify it down to hopefully one thing. We don't always get it down to one thing, but a lot of times we can take any messy trig function or trig expression and simplify it down to a piece or two, which is kind of the idea. Okay, so this first one is the example that's on the front of the packet. Okay, so we'll just walk through it so you can see where all the steps come from. Okay, so I look at it, I have no idea what tangent divided by secant is. They switched from using thetas to using x's. Who cares? Like, we can put whatever we want in the spot of those angles, so get used to just seeing different things. But what is tangent? Okay, well, I can look over here and I see that tangent is nothing more than sine over cosine. So that's what I'm going to do. Okay, I'm going to take tangent, I'm going to rewrite it as sine over cosine. And since they used x for the angle, I'm going to use x for the angles. I'm going to do the same thing with secant. Okay, what is secant? Well, I look over here at my identities. I see that secant is 1 over cosine. Okay, so I'm going to take secant out. I'm going to replace it with 1 over cosine. Okay, and then this is just really similar to the proof we did on that first video, showing that sine over cosine equals tangent. It's actually the exact same process, just with different things substituted in. So it's really the same proof. Because here I have a fraction divided by a fraction. Okay, how do I do that again? Well, a fraction divided by a fraction is the same thing as taking a fraction and multiplying it by its reciprocal. Okay, so that's something that we should use all the time in algebra, or should use often enough that we're comfortable with it, but if we're not, it's a chance to review that. Okay. And we see that by doing that and getting rid of the bottom here, we have the same situation we had with the proof of tangent from the first video. We see that these cosines have 1 on the top, 1 on the bottom, so when I multiply them together, these guys should cancel out. And I'm just left with sine x over 1, which is just sine of x. Okay. And what you just did, again, it's just basically it's an algebra proof. So you've just proved that tangent divided by secant is always going to be sine. Okay, so no matter what I put in for that angle, if I take the tangent divided by the secant, I can always just simplify that down to the sine. It's always going to be the exact same answer. And so I can use that. So if I'm like working with something down the line, pre-calc, calc, whatever, and I have an expression like this, I'm going to get rid of it. I'm going to simplify it down to this so that it's easier to work with from there on out using this identity that we have now created. Okay. Which is also kind of neat, because we started with 8 fundamental identities, but actually every time we do one of these, every single example we do, we're actually making a new identity to add to this list. Okay, now we're not going to write them all down, because that would just become, again, crazy, because there are thousands of different combinations that we could run into. But this is one of them. Is very, very simple. Anytime I have these two things divided, it'll always end up as sine. Okay, and that's the idea behind this whole section, or this whole little mini unit that I'm trying to do for you. Okay. So example 2 is not on the front page here, but I just wanted to run you through another one just so that you can kind of see, okay, here's what we're doing. Okay, so this one, sine x times cotangent x. Okay, by itself, doesn't tell me a whole lot. So what do I do? Okay, if I have things multiplied together, it's a good chance to turn stuff into sines and cosines and hope that something cancels. Okay, because that's what we did up here. Turned it into sines and cosines, stuff canceled. Okay, well, sine is just sine. We can't really do much with that. Okay, so we're going to leave sine alone. Because sine and cosine are kind of our starting point. Like if you look at all of these different identities, especially the ones up here, we can turn almost everything in the sine. Actually, we can turn everything in the sine and cosine. Because this one is the same as this one. So we can always get it there. That's why we use sine and cosine. Okay. Times cotangent. Okay, well, cotangent, if I write it in sines and cosines, cotangent is cosine over sine. So times cosine over sine. Okay, and then you look at it, and basically this is one big fraction. Sine times cosine is on the top. There's technically a 1 underneath here. Okay, and all of a sudden it's really, really similar to what just happened here. The sines will cancel. There's that 1 on the top, 1 on the bottom, and all that's left is cosine. Okay, so for all of time, no matter what I put in, sine times cotangent will always be the exact same thing. We'll always simplify down to cosine. Okay, so that's your first strategy. It gets used a lot. Again, if you have multiplying and dividing going on with your trig functions, turn them all into sines and cosines, see what cancels, see what simplifies. A lot of times something will.